actually interact with the core concepts of calculus every time you look at a car dashboard. The speedometer tells you your exact rate of change at one specific instant. It is a measurement of the now. On the other hand, the odometer tracks the total distance you've accumulated over the whole trip. These two ideas, measuring the instant and measuring the total, are the two halves of the story. To see how this works, we can visualize this journey on a graph. This curve shows the distance the car has traveled over several minutes. Looking at the whole trip is easy, but what if we want to know our exact speed at one highly specific moment, like at exactly the 12-minute mark? To find the answer, we have to zoom in on that one specific spot on the curve. We freeze the motion, turning that moment into a single dot on the graph. If we lay a straight line across that dot so it just barely grazes the curve, we can see the exact angle of our journey at that second. Mathematicians call this a tangent line, and its steepness tells us our exact speed. This act of finding the steepness of a single point is called a derivative. A derivative allows us to take a continuous, fluid movement and slice it down into an infinitely thin moment to see exactly how fast it's changing. Now, let's look at a different graph. This time, we're tracking speed instead of distance. If we only have a record of our speed at every second, how do we calculate the total distance we actually traveled? We start by taking one slice of speed at a single moment. Then we track our speed over every second of the trip, adding them up side by side. As we fill the area under the curve, we are actually calculating the total distance accumulated during the drive. This process of building up the total area is called an integral. Integration answers how much by adding up an infinite number of tiny snapshots to find the total result. When we place these two ideas next to each other, a pattern emerges. With a derivative, we slice a whole journey apart until we're left with the speed of a single moment. With an integral, we glue those moments back together to find the total journey. Isaac Newton and Gottfried Leibniz discovered that these two processes are exact opposites. They are two different ways of looking at the same movement. This connection is known as the fundamental theorem of calculus. It proves that taking a whole apart and building it back up are mathematically linked. If you know how to do one, you can find your way to the other. This is why we use symbols like the derivatives d over dx or the integral's long flowing s. These symbols act as instructions for the actions we just saw. One tells us to slice a curve into pieces, and the other tells us to sum those pieces back together. By mastering these two movements, we can calculate everything, from the trajectory of a rocket to how populations grow over time.